Hello my dear students, welcome again. In the last class, we've been in a discussion with complement of a function, and you understand that how to complement a given function. At the same time, if we apply duality, we can also get the complement of a function. That's all we have discussed in the last class. Fine. So today's topic is canonical and standard form. This is one of the important topic for your examination also, for your knowledge, or for any other competitive exams which you appeared from computer science. Okay, we have to understand some standard forms are there, or we can also have canonical forms. We will discuss all these together. So to understand this topic, you should know some basics like ANDing, ORing operations, correct? Okay, here we have to discuss two more important terms. Those terms are called as mean terms, okay, mean terms, and one more important term, that is called as max term, min term or max term. Okay, say a binary variable may appear either in its normal form. What is normal form? Say a variable may be x, this is a normal form, or this variable may be appears in its complement form. What is the complement form now? Complement form is nothing but x bar or x prime. This is a complement form. Now, if I consider two binary variables, say x and y, okay, and which is combined with AND operation, alright. If it is combined with AND operation, how to write this? That is x y, correct? Okay, since each variable may appear in either form, each variable in the sense what? X and y, these two variables may appear either in a normal form, either in a normal form, or these may appear in complemented form or complement form, I can write. How many possibilities we can have right now? For these, if I consider two variables x and y, the combinations are like this. I can write both are primed, x bar y bar, this is one combination, and the other one is x is primed, y is normal. Third one is x is normal, y is primed, and the last one is x is primed, sorry, x is normal and also y is normal. These many combinations we can have if I consider two variables. Am I right? If I consider only one variable, say if I consider only z, z may be appear in the normal form z, or it may be appeared in the complemented form z bar. Okay, the same way if I consider two variables, how many possibilities I have written? I have written four possibilities, correct? What it means? If n variables are there, okay, the total number of combination for these mean terms may be 2 to the power n. Now you can see how many variables we have? Two variables, it means that n equals to 2. How many possibilities we can have? That is 2 to the power n. Here 2 to the power n is nothing but 2, that is 4. Now you check 1, 2, 3 and 4. Am I right? Okay. The same way, if you have three variables like x, y and z, then the total number of possible combinations are 2 to the power n. 2, how many variables are there? N is equals to 3 here, so 2 to the power 3 is equals to 8 combinations you can have. So I will write those combinations now with a table. Okay. Okay, now I have written here, if I consider two variables, I have written x prime y prime or x bar y bar, x bar y, x y bar and x y. These are nothing but mean terms. Okay, once again I will tell you, if I consider two variables, how many combinations I have written? X prime or x bar y bar, x bar y, x y bar, x and y. These are performed with which operation we have performed here? We performed AND operation. Any operations or any term which is performed with the AND operation is called as mean term, is known as mean term. Here this is also mean term, this is also mean term, this is also mean term and this is also mean term, or you can call this mean term as standard, what I can call standard product, correct? Product in the sense multiplication, right? X, here multiplication operation is performed, right? So that you can also call this as a standard product. Okay, in a similar manner, if you have n variables, how many combinations or how many mean terms you can have? If n variables are there, then 2 to the power n mean terms we can get. This is the concept of mean term. So I will write one table, you can understand what is the mean terms. You already understood with the two variables how to write mean terms. Now I will write one table for three variable mean terms. That is, I take variables as x, y, z. How many variables are here? 3. 3 means what? N is equals to 3. How many combinations we can have? 2 to the power n. 2 to the power n, n is 3, so 8 combinations, right? So this is x, y, z. Okay, I will write the values in this table, that is 0, 0, 0, 0, 4 possible zeros for x, 4 ones. Here 0, 0, 1, 1, 0, 0, 1, 1. The last one is 0, 1, alternative zeros and ones, 0, 1, 0, 1, 0, 1, correct? Now here I will write here we can write mean terms. Mean terms. Okay, mean terms. What are the mean terms we can have? That's all I will write here. Mean terms. Okay. First I will write term here. Term here. What is the designation? I will tell you how designation can be written. Okay. Okay. And one more thing you have to remember, that the mean term always produces result as, mean terms produces result as 1. You understand this? It produces result as 1. You remember this. And mean terms always ANDing operation. These two are very important. Mean terms always ANDing operation which produces result as a 1. Correct. So to write the mean term for the first combination, what is the first combination here? This is the first combinations, right? Okay. To write mean term for the first combination, how to write mean term? You already know that which produces result as 1 and which is, or we have to perform ANDing operation, correct? So to perform AND operation, you just consider three variables. What are the three variables we have? X, y, z. What is the value? X is 0, y is 0, z is 0, right? So to write, we have to obtain result as a 1. If I write x dot y dot z, if I put values, what is x value? 0. What is dot? What is y value? 0. Dot. What is z value? 0. 0 dot 0 dot 0, which is equals to 0. But I told you that it will always produce result as a 1. So that what we have to write in case of this, if it is 0, we have to make it is prime. If it is 0, we have to make it is prime. This is also 0, you make it is prime. Then you check x is 0, then what is x prime? That is 1. Y is 0, correct. What is y prime? 1 dot. Z is 0, correct. What is z prime? 1. 1 dot 1 dot 1 is equals to 1. Yes, the result is 1. It means that for writing mean term, wherever zeros are there, you just write complemented term. Wherever 1 is there, you just write normal term. So here what I have to write, and with the ANDing operation. So okay. Here what I have to write, x is 0, y is 0, z is 0. So that x prime, y prime, z prime. These three variables are performed with the ANDing operation. That's it. Okay. Here x is 0, y is 0, then z is 1. So I have to write x prime, y prime, z. Here x prime, y, z prime, x prime, y, z. So that x, y prime, z prime. Now x prime, y, sorry, this is just x because 1 is there. Okay, this is x, y prime, just z, x, y, z prime, x, y, z. If you have any doubts, you just check it with the with putting zeros or ones into the term whatever you have written. So now I will show one example, that is here if I consider this row, what is the value of x? X is 1. What is the value of y? Y is 0. What is the value of z? Z is 0. Okay, what we have written the terms? X, y prime, z prime. So x, y prime dot z prime. If I put the values, x is 1, so 1 dot. What is y? Y is 0, y prime is 1. Z is 0, z prime is 1. So that 1 dot 1 dot 1. Yes, I got the result as 1. So that this is how you can write mean terms. What is the designation for this mean terms? Wherever, okay, it is very simple. The first combination, wherever values are all zeros, that is nothing but mean term 0. This is mean term 1. This is mean term 2. This is M3 or mean term 3, mean term 4, mean term 5, mean term 6, mean term 7. How many mean terms we have? The total mean terms we have 8. Correct? Because from 0 to 7 means 8 mean terms we have. Already you know that there is a formula which I have written already, that is 2 to the power n, 2 to the power 3 is nothing but 8. So 8 mean terms we have. I think this is clear to you how to write mean terms. Mean terms is always ANDing operation which will give the result as a 1. Okay. If you consider 3 variables, you will get 8 combination. If you write 4 variables, you will get 16 combinations, and like that. If you only write 2 variables, then you will get 4 combinations. This is all about mean terms. Okay. So formally you can say a Boolean function can be expressed algebraically from a given truth table. Okay, this term which I have shown in this table, it is all about mean terms. One more thing you have to understand in this topic, we can also write function for the given mean terms. You know about function, what is function and how to write a function, how to complement and how to simplify the given function. That is all we have already discussed in the previous classes. So if I consider this table, can I write function? Yes, you can write the function. That is, say for example, if I write function f1, consider any of the mean term here. I will take whatever the terms if you want to write, you can write for the function. Say for example, if I write, I will consider this one. This is for example m1 plus m4 plus I consider this and m7. By considering these mean terms, how I can write function? The function for mean terms is always odd function with the mean terms. Mean terms always, it should, the function from the mean term should produce the result as a 1. So that how to write the function here? What is m1 here? m1 is nothing but, you consider this now. m1 means what? X prime y prime z, x prime y prime z plus, what is m4? X y prime z prime, x y prime z prime plus, what is m7? m7 is x y z. I told that mean terms always produce result as a 1. At the same time, the function which obtained from the mean term should produce the result as a 1. So now you check x, what is function m1? m1 is nothing but 0 0 1, correct? These are the values 0 0 1. 0 0 1 means 0 becomes 1, this is 1, this is 1. X y prime, this is 1, this is 1, this is 1, because x is 1, y is 0, it becomes 1, z is 0, it becomes 1. You check here, here m4 is there, okay. The last one is x y z, x is 1, y is 1, z is 1, you see here it is, okay. Okay, and what I have done, I performed OR operation between these mean terms. Remember this, for writing mean term function I used OR operation with mean terms. These are the mean terms, this one, this one, this one, these are the mean terms, right? You see m1 is a mean term, m4 mean term 7. So operate with the plus, what you will get, 1 1 dot 1 dot 1 dot 1 is 1 plus 1 dot 1 dot 1 is 1 plus 1 dot 1 dot 1 is 1. So the result is 1. What? Here you understand that function f1 gives the result as 1. Whatever may be the function in this mean term, if you consider, you can consider m6, m8, m9, sorry m9 is not there, so m2. If you add these, you will get the result as 1 only. This is all about mean terms. I hope you are getting. Okay. The same way we can have one more term which is known as max term. Okay, that is called as max term. I will write max term very easiest way here. Again, you have to consider term and designation. So I will write that. Here I will write max term. Okay. Okay. I will write a term here or terms, and here designation. Okay. Max term, for understanding this max term, I will write some note here. Max terms always produces result as 0. Mean terms produces result as 1, but max term produces result as 0. And what we have performed with the mean terms? Mean terms is nothing but ANDing operation performed with the variables. In the max term is not ANDing, it is ORing. Okay, this is ORing operation. So let me explain with two variables max term. If you consider, first I will explain with one variable. Again we have only x or x bar. You cannot perform any operation between single variable, only complementation we can do, right? So if I consider two variables, how many combinations I can write? Again 4 combinations, that is x plus x or x plus x bar, correct? X bar plus x and x bar plus x bar. These are the combinations we can write for the max time. In the same way, if you consider 3 variable, how we can write? X bar plus y bar plus z bar, like this, x bar plus y bar plus z, x bar plus y plus z, like this. You can write 8 combinations for 3 variable max term. Here if you observe, I have written OR operation between these 3 literals or 3 variables. This is max term. And one more thing you have to remember, that max term always produces result as 0. Okay, you will understand how it will produce result as a 0 by the above table already we have written, right? Okay, now you consider here first combination is what? 0 0 0. Okay, I will write wherever zeros are there, you just write x, y is also 0, so plus write y, z is also 0 plus z. This is the difference between max term and min term. Wherever zeros are there in min terms, you return primed variable. See, x is 0, but x is 0, so I written as primed variable x prime dot, y is 0, I written y prime, z is 0, I written z as a, sorry, this is z prime. Okay, this is z prime. Okay, z prime. But here wherever zeros are there, you just write unprimed variable, that is x is 0, so write as usual x plus y plus z. Okay, here 0 0 1, how to write that? X plus y plus, wherever 1 is there, you write unprimed variable, that is z prime. Correct. So here third one is x prime plus y plus z prime, x prime plus y plus z, x prime plus y plus z. Sorry, I have written mean terms here. I will write once again these. Wherever zeros are there, you just write simple variable or normal variable, x plus y plus z prime. Here x plus y prime plus z. Here x plus y prime plus z prime. Okay, x prime plus y plus z. So x prime plus y plus z prime, x prime plus y prime plus z. Okay, x prime plus y prime plus z. Now you put the values with any of these max terms, you will get the result as 1. So which one I have to consider? Before that I will write directly designation for this mean term. Max term, mean term is designated with the small m, correct? The same time max term is designated with the capital or uppercase letter. This is m0, m1 means max term 0, max term 1, max term 2, m3, m4, m5, m6, m7. Okay, now you consider any of the max term here, so I will write whatever m3 I will write. What is m3 now? m3 is combination, I will check 0 1 1. Okay, 0 1 1, I will write combination for m3 is 0 1 1. What is the term here? X plus y prime plus, now is here 0, so put 0. Y is prime, this is x, this is y, this is z, right? Y is 1, put 1 here, 1 becomes 0 because you can, this side we have y prime plus z is 1, if you put here z, or if you put here z becomes again 0, 0 plus 0 plus 0, you will get 0. Okay, I told that it will produce always result as a 0. Now you check another example, m5. m5 means what? X prime y plus z prime. You check the combination 1 0 1. So I will write m5 that 1 0 1. Now you put the value. How to write the term here? Term is like this, x prime plus y plus z prime. So put the values of x, y and z. X is 1, 1 becomes 0 because here it is prime. plus y is 0, here not prime, so simply you put 0 plus z is 1, here z prime is there, put 0, 0 plus 0 plus 0 is 0. This is how we can write min terms and max term. Okay, these are very important terms, and you write this table. Okay, and here you have to remember 3 or 2 important standards, that is, by the table or by the min terms max terms we have observed. I will write that note here as a note. Okay, what is that? Any Boolean function can be expressed as sum of mean terms. I just write that only. Any Boolean function can be expressed as sum of mean terms. This is one note, and other one is any Boolean function can be expressed as product of max terms. Product of max terms. What is sum of mean terms? Yes, I have already written one function for that, m1 plus m4 plus m3. This m1, m4, m7 are the mean terms, right? These mean terms are ORed, correct? These are the mean terms, and we have ORed, so that I can call that as a sum of mean terms. I will write that m1 plus m7 plus whatever you take, m8, sorry, m8 is not there. If you want to write what are the combinations you have, you can write those. m1 plus m3 plus m4. This is what? Sum of mean terms. It means that mean terms are summed together. Product of max terms means what? m1 dot m3 dot m4. This is product of max term. You can put the values in this, that is m1 dot m3 dot m4. What is m1? m1 is 0 0 1. Next m3 is what? m3 is 0 1 1, and last one is m4. If you put m4, that is 1 0 1, you will get the result as 0. So I can also write this as a function 1 equals to this, function 2 is equals to this. This will produce the result as 0, this will produce the result as a 1. This is all about mean terms and max terms. In the next class, we will discuss about sum of mean terms and product of max terms. Okay, thank you.